On December 30th, 2025, search vessels entered the remote southern Indian Ocean. For the third time in 12 years, the hunt for MH370 had begun. This time, many believed it would just take one final sweep. But just 3 weeks later, the search was paused. The ships turned around. For the third time in over a decade, the most expensive search in aviation history ends the same way, looking in an ocean that may not contain the plane. Because buried in the data are contradictions no one talks about. Satellite pings that don't agree with radar, drift models that can't explain the debris, and depth maps showing entire regions the search technology physically cannot reach. And theories suggesting something far darker than a simple crash, including one that questions whether MH370 is even in the Indian Ocean at all. To understand how this latest attempt fell apart, we need to quickly revisit what we already know. March 8, 2014. Malaysia Airlines Flight 370 took off from Kuala Lumpur as a routine flight to Beijing. About 40 minutes later, the transponder suddenly shut off. Military radar later showed the aircraft turning back across Malaysia, flying northwest and then heading south into the Indian Ocean. After that, it vanished. The plane simply disappeared. But not entirely. Inmarsat satellites kept recording automatic handshakes with the aircraft for 6 more hours. These weren't GPS coordinates, just signals showing the plane's satellite system was still powered up and trying to connect. Those signals created arcs across the ocean. The 7th and final arc at 8:19 AM became the main search zone. Somewhere along that line, MH370 ran out of fuel and went down. Debris started washing up in July 2015. A flaperon on Reunion Island, wing pieces in Mozambique, interior panels in Madagascar, 33 confirmed pieces total, scattered across the western Indian Ocean and African coastline. Every single piece proved the plane ended in the ocean. Every piece helped refine the drift models pointing back to a crash site somewhere in the southern Indian Ocean. Australia, Malaysia and China funded a massive search from 2014 to 2017. They covered 120,000 square kilometers, found nothing. In 2018, Ocean Infinity came in on a no find, no fee deal and searched another 112,000 square kilometers. Still nothing. Total area searched by early 2025, 232,000 square kilometers. That's roughly the size of the United Kingdom. Then late 2025, Malaysia approved Ocean Infinity's proposal to try again. New technology, refined search zone, a 15,000 square kilometer box based on updated data. December 30th, search begins, and just after 16 days on January 15th, 2026, it was paused again. Now let me show you why this keeps happening, why every search fails, why this mystery has become genuinely impossible to solve. Because the problem isn't just that the ocean is big, the problem is they might be searching the wrong part of the ocean entirely. And the terrifying part? They know it. There are specific zones that independent researchers believe are the most likely crash sites. Zones they have identified through years of analysing ocean currents, debris drift patterns, and satellite data. One zone is called the Caption Yellow Triangle, coordinates 35.7 degrees south, 93 degrees east. Jean-Luc Marchand and his team spent years on this. They tracked every piece of debris backward through ocean currents, calculated drift speeds, factored in wind and seasonal changes, and everything pointed to this specific spot on the map. Ocean Infinity didn't search it. Not in 2018. Not in 2026. It sits completely outside their search box, untouched. Then there are multiple independent research groups have identified other high probability zones outside Ocean Infinity's search area. Different locations, different methods, but all pointing to the same conclusion. Ocean Infinity is looking in the wrong place. Even independent researchers and aviation experts like Jeff Wise have been posting detailed breakdowns showing how Ocean Infinity's chosen area doesn't match the physical evidence. And it gets so much worse when you bring in glide theory. See, the official assumption for most searches has been that MH370 ran out of fuel and dropped from the sky in a steep, uncontrolled dive. That keeps the crash zone relatively tight, maybe a few dozen kilometers on either side of the 7th arc. This video is sponsored by Speedcube Shop, and if you're obsessed with puzzles like MH370, why not have a fun one to keep your hands busy too? A speed cube is the upgraded Rubik's Cube, lighter, smoother, with magnets so the layers snap into place and it never locks up. Great desk fidget, great for kids' focus and problem solving. And if you can't solve one yet, they have a free step-by-step guide for beginners. And the coolest part of Speedcube is that they only stock the brands that actually matter: GAN, Moyu, Qi. None of that cheap knockoff stuff. Fast shipping, free US shipping over $59, and 90-day returns. Link at the top of the description. Now back to the video. We discussed how every search has failed. But what if the pilot stayed conscious and in control after fuel ran out? What if they glided the plane? A Boeing 777 gliding from cruise altitude could travel 70 nautical miles. Maybe more, maybe 100. If that happened, the search area doesn't expand a little, it explodes. You're not looking at a narrow band anymore. You're looking at a massive oval extending far beyond anything that's been searched. Tens of thousands of additional square kilometers that nobody has even touched. The math is brutal. If the plane glided just 50 nautical miles beyond what the models predict, then every single search since 2014 has been looking in the completely wrong place. But let's say tomorrow, Ocean Infinity announces they've pinpointed the exact crash coordinates with absolute certainty. Even then, the data that got them there is broken, because every single clue we have contradicts every other clue. Then there's Weak Signal Propagation Reporter, known as WSPR. It's a global network of radio receivers that track disturbances in radio wave patterns. Some researchers claim you can use these signals to track aircraft by identifying how they disturb radio waves as they pass through. Think of it like an invisible web of radio signals covering the entire planet. Thousands of amateur radio operators transmitting low-power signals that bounce around the atmosphere. When a massive metal object, like a Boeing 777, flies through these signals, it creates disturbances, like tripping a wire. The signal bends slightly, delays by milliseconds, changes strength, and those changes get recorded. By going back through archived WSPR data from March 8, 2014, researchers identified hundreds of these disturbances. They connected the dots and created a flight path. Not just random points, a continuous track showing deliberate turns, altitude changes, a path that suggests someone was actively flying the plane. And that path? It leads to a crash location hundreds of kilometers away from where Ocean Infinity is currently searching. A completely different part of the ocean. Now, the mainstream search community dismisses WSPR as unproven, unreliable technology. Okay, fine. But then what about the University of Western Australia's drift models? UWA spent years analysing ocean currents, wind patterns, seasonal variations, trying to back-calculate where debris found on African beaches originated. Their models? They point to crash locations that don't match Ocean Infinity's area either. Then you've got Catherine T., British sailor crossing the Indian Ocean on March 8, 2014. She reported seeing an aircraft trailing black smoke and orange flames at a position that doesn't line up with any of the official search zones. She filed a report, authorities noted it, and then everyone just moved on because it didn't fit the satellite data. And what about the emergency locator transmitters? Every commercial aircraft has ELTs that automatically activate on water impact. They float, they broadcast distress signals. MH370 had 4 of them. Not one activated. Not one was ever detected. That could mean the impact was so catastrophic they were instantly destroyed. Or it could mean something else happened entirely. Even the flaperon, the very first piece of debris found, creates massive problems. Drift models predicted it would take way longer to reach Reunion Island than it actually did. When it showed up early, oceanographers had to completely revise their calculations. They started adding new drift mechanisms just to make the math work, the kind of adjustments that make you wonder how reliable these models ever were. So you've got WSPR pointing one direction, UWA drift models pointing another, eyewitness sightings pointing somewhere else entirely, satellite arcs defining one search boundary, debris patterns contradicting timeline predictions, emergency beacons that never went off. Every single data source tells a different story. There's no ground truth where everything lines up, just fragments of contradictory information, and searchers have to pick which fragments to trust and which to ignore. And here's what makes it even worse. The Indian Ocean isn't like the Atlantic or Pacific. In those oceans, currents are relatively predictable. They flow in consistent patterns year-round. But the Indian Ocean? It's chaos. Seasonal monsoon winds change direction throughout the year, which means the currents change direction too. Debris doesn't travel in straight lines. A piece of wreckage can spend months trapped in a slow-moving eddy, barely moving at all. Then suddenly, it enters a faster current and shoots thousands of miles in a completely different direction. Cold, sub-Antarctic waters move eastward along the bottom, while warmer surface currents curve north toward Africa. It's layers of movement going in different directions at different speeds. That's why drift models keep failing. They're trying to predict where debris came from by tracing it backward through an ocean that behaves differently every season. Even small differences in where the plane hit the water, just a few miles, could result in debris washing up on completely different coastlines years apart. Ocean Infinity picked one set of data. Other researchers trust completely different sets. And if Ocean Infinity chose wrong, which multiple experts believe they did, then it doesn't matter how advanced their technology is. It doesn't matter how many square kilometers they scan. They're searching the wrong ocean. Which brings me to the question that's haunted this case since day one. How do you find a missing plane when you don't know where it is, your data contradicts itself, and every analytical method points somewhere different? You look at the only time in history someone actually pulled it off. You look at Titanic. Because Titanic is the reason we think finding MH370 is even possible. But the Titanic story is also the answer. They never will. April 14th, 1912. Titanic hits an iceberg in the North Atlantic. 2 hours and 40 minutes later, it's at the bottom of the ocean. More than 1,500 people died. But here's the thing about Titanic. Everyone knew roughly where it went down. They had distress calls. They had survivor accounts. They had the last known coordinates radioed out before the ship disappeared. 41.7 degrees north, 49.9 degrees west. The search area? About 100 square miles. And the depth? Around 12,500 feet. 73 years it stayed hidden, not because nobody tried to find it, but because the technology didn't exist yet. Then, in 1977, Robert Ballard makes his first attempt. Fails. Equipment breaks down. But Ballard doesn't give up. He approaches the US Navy with a proposal. He's got new technology, a towed camera sled called Argo that can capture live video from the ocean floor. The Navy is interested, but not in Titanic. They want their submarines back. See, during the Cold War, the US lost 2 nuclear submarines, the USS Thresher in 1963 and the USS Scorpion in 1968. Both imploded at depth, both carrying nuclear reactors, both sitting somewhere on the ocean floor, and the Navy had no idea what condition they were in or if they were leaking radiation. So they cut Ballard a deal. Find our subs first. After that, whatever time you have left, you can look for Titanic. Ballard agrees. And this is where everything changes. Because when he finds those submarines, he discovers something crucial. They didn't just sink intact, they imploded. And when they imploded, they scattered debris everywhere. Massive trails of wreckage, spreading over a nautical mile or more. Not just one target on the seafloor, dozens, hundreds. A field of metal and machinery scattered across the ocean floor. That's when Ballard has his breakthrough. Don't look for the ship, look for the debris field. A debris field is a way bigger target than a single intact hull. It spreads over a massive area, easier to spot with sonar, which are basically underwater radar that uses sound waves to map the ocean floor. Instead of trying to find one needle in a haystack, you're looking for dozens of needles scattered across a much wider area. August 1985, Ballard gets his shot. He's got 12 days left after finishing the submarine missions. 12 days to find Titanic. Day 1 to 3. They sweep the search area using the known coordinates from 1912. They're working in a 100-square-mile box. Days 4 to 7. They deploy Argo and start looking for debris. Not the ship itself, just pieces. Anything that doesn't belong on the natural seafloor. September 1st, 1985, 1:40 in the morning, they spot a boiler, then another, then pieces of hull plating. They follow the debris trail like breadcrumbs, and it leads them straight to the main wreckage. 8 days of actual searching, 73 years after it sank. And here's why it worked. Titanic had a known location, not exact, but close enough. 100 square miles instead of hundreds of thousands. It had manageable depth. 12,500 feet was right at the edge of what 1985 technology could handle, but it was doable. The conditions? The North Atlantic isn't calm, but it's nothing compared to the southern Indian Ocean. And funding? Unlimited. The US Navy was footing the bill. Black budget, no questions asked. Ballard could return as many times as needed. Plus, he had a strategy that worked. He'd practiced on 2 submarine wrecks. He knew what to look for. He knew debris spreads. He knew how to follow trails. It was basically a proven playbook by the time he got to Titanic. So you had known location, manageable depth, decent conditions, unlimited money, and a proven strategy. MH370 has none of that. Not one. Let me show you just how different this is. The search area for Titanic was tiny, just 260 square kilometers. They knew roughly where it went down from distress calls and survivor accounts. MH370? The potential crash zone is 2 million square kilometers. That's not a little bigger, that's 8,000 times larger. And it's not even a defined location. It's calculated from satellite pings that give you arcs, not points. Each arc is thousands of kilometers long. You're not searching a spot, you're searching a line across an entire ocean. And you don't even know which part of the line to focus on. If we talk about depth, the Titanic was at 3,800 meters, manageable for 1985 technology. MH370, however, is sitting anywhere from 4,000 to 7,400 meters deep, nearly twice as far down. And here's the problem. Current autonomous underwater vehicles are rated to 6,000 meters maximum. If MH370 went down in over 7,000 meters of water, which parts of the search zone definitely are, current technology literally cannot reach it. It's physically impossible. And even at 6,000 meters, you're at the absolute limit of what these machines can handle. The pressure down there is 700 times atmospheric pressure. It crushes steel. It implodes submarines. The autonomous underwater vehicles known as AUVs are basically robot submarines equipped with sonar that scan the seafloor on their own. They're operating right at the edge of their capabilities. And that's when things break, which is exactly what happened in the 2026 search. Multiple mechanical failures. Multiple times they had to pull AUVs back to the surface because something went wrong. You can't just send a repair crew down there. You have to bring the entire vehicle back up, fix it, and redeploy. Every failure costs days. Now let's talk about terrain. Titanic landed on a relatively flat abyssal plain. Some slopes, some sediment, but mostly just a flat sea floor. Easy for sonar to map. Now compare that to MH370's search zone. It's an underwater mountain range. The Broken Ridge, volcanic formations. The Diamantina Trench with escarpments dropping 1,200 meters straight down. Slopes steeper than expert ski runs. Underwater mountains rising over 1,000 meters. Mass wasting zones where underwater landslides happen. From 2014 to 2018, search teams used towed sonar systems. Long cables dragging equipment miles behind ships. They couldn't get close to rough terrain. When sonar waves hit a ridge, everything behind it became a shadow. Complete blind spot. In 2016, one of those towed systems slammed into an underwater mud volcano because the terrain was so unpredictable. Even today's autonomous underwater vehicles have to fly 100 to 150 meters above the seafloor to stay safe. Anything in a canyon, behind a ridge, tucked into a crevasse, missed entirely. And volcanic rock scatters sonar signals, false returns that look like debris but are just natural formations. It's entirely possible search ships passed directly over MH370 and never saw it because the terrain hid it. Now add time into the equation. Titanic was found 73 years after it sank, but it was still largely intact. The cold water at depth slows decay. Metal lasts. But MH370 has been down there for 12 years. And 12 years is long enough for serious problems. In some areas of the southern Indian Ocean, you get 1 to 10 centimeters of sediment per year. After 12 years, you could have over a meter of burial. The wreckage doesn't just sit on the seafloor, it gets covered. Marine growth, barnacles, organisms attach to surfaces and make sonar returns blend in with the natural environment. The ocean down there is cold, 1 to 2 degrees Celsius, so metal does preserve better than in shallow, warm water. But biological and geological processes are still active. Sediment moves, currents bury things, and the longer you wait, the worse it gets. There are sub-bottom profilers that can see through sediment, but they only penetrate 1 to 2 meters deep, and they're not reliable at all depths or in all terrain types. If MH370 is buried deeper than that, those tools are useless. And we haven't even talked about weather yet. But before we get to weather, let me tell you about the one advantage the 2026 search actually has. Because Ocean Infinity's technology is genuinely impressive. They're not using towed sonar anymore. They're using swarm robotics. Multiple Hugin autonomous underwater vehicles working together in coordinated patterns. These aren't tethered to the ship. They dive to the seafloor independently, navigate around obstacles, and scan in formations that cover way more area than old towed systems ever could. And the sonar they're using? It produces picture-like images of the seafloor, high resolution enough to see details. Plus, they've got onboard AI that processes data in real time. The AI can differentiate between natural geological features, rocks, ridges, sediment, and man-made objects like aircraft debris. It recognizes the geometric patterns of manufactured metal versus the irregular shapes of nature. This is cutting-edge technology, the best we have. And even with all of that, even with autonomous drones, AI recognition, high-resolution imaging, swarm coordination, the 2026 search still collapsed, still paused after covering less than half the planned area, still found nothing. If the best technology we have can't do it, what does that tell you? Titanic was in the North Atlantic. Tough conditions, sure. Storms, cold, rough seas. But it's accessible year-round if you plan for it. The southern Indian Ocean is different. It's not just rough. It's the most hostile marine environment on Earth. Wave heights regularly hit 3 to 5 meters. Storms push them to 10 meters or more. Wind speeds are consistently over 25 knots. The 2026 search got shut down by 4.4 meter waves and 25 knot winds. Those aren't even extreme conditions for that region. That's normal. You only get a 3 to 6 month weather window per year where searching is even possible. December through March, maybe. And even during the good season, storms blow through constantly. The 2025 search had to pause in April because the weather turned. The 2026 search launched in December, and by late January, they were fleeing to port. You can't launch or recover AUVs in heavy seas. It's too dangerous. The ships have to run. Every weather delay costs millions in operational expenses. Every delay means less area covered. And Ocean Infinity is absorbing all of those costs. Which brings me to the money. Ballard had unlimited funding from the US Navy. MH370, Ocean Infinity is operating on a no-find, no-fee contract. They only get $70 million if they find the wreckage. If they don't find it, they get nothing. Every day they're out there searching costs them money. Fuel, crew salaries, equipment wear, ship maintenance. Every weather delay costs them money. Every mechanical failure costs them money. And if the plane is outside their search zone, they've spent all that money for nothing. From 2014 to 2026, the total spent on MH370 searches is over $200 million. Australia, Malaysia, and China spent $155 million on the initial search. Ocean Infinity spent tens of millions in 2018 and got nothing. Now they're spending more in 2025 to 2026. For what? A $70 million payout if they succeed. Here's the brutal economic reality. It's cheaper for governments to compensate the families than to keep funding searches. Malaysia Airlines paid out roughly $410,000 per victim. For 239 people, that's about $98 million. Compare that to the $200 million already spent searching, with no end in sight. Why would Ocean Infinity expand the search indefinitely? Why would any government commit another $100 million when they could just close the case and move on? But you know what? The worst problems are the ones that have nothing to do with technology or money or weather. In fact, the worst problems are the ones that make you question whether MH370 is even in the ocean at all. Let's talk about the numbers that prove this case is unsolvable. Ocean Infinity's 2026 search covered 7,236 square kilometers in almost 2 weeks. That's roughly 300 square kilometers per day. Now, the current target area, based on refined satellite data and drift models, is about 15,000 square kilometers. At their current pace, finishing that would take about 50 days of actual searching. But here's the problem. If glide theory is correct, if the pilot stayed in control and extended the range, the potential search area isn't 15,000 square kilometers, it's 2 million. 2 million square kilometers. At 300 square kilometers per day, covering 2 million would take 6,666 days. That's over 18 years of continuous searching. Just non-stop searching for nearly 2 decades. And that's assuming the technology stays operational, the funding doesn't run out, and Ocean Infinity is willing to absorb costs for 18 straight years with zero guarantee of that $70 million payout. It's not happening. Let's look at the probability. If MH370 is sitting in 7,000 meters of water or deeper, current AUVs can't reach it. That rules out huge portions of the search zone immediately. Let's say there's a 10% chance the wreckage is at unreachable depth. If it landed in rough terrain, sonar might not detect it, even if they pass directly over it. Add another 20% chance it's hidden by terrain. If it's buried under more than 2 meters of sediment after 12 years, sub-bottom profilers won't see it. Another 15% chance. If the debris scattered over a wide area and the pieces are small enough, they'll look like natural geological features on sonar. Another 25% chance of being invisible. And if the pilot glided beyond the 7th arc, outside every zone that's been searched or planned, it's not even in the searchable area. Another 30% chance. Start combining those probabilities. The chance of MH370 being both locatable and detectable with current technology in the zones being searched, it's approaching zero. And we're not even talking about the biggest issue yet, the fact that the search zones keep changing. The original search from 2014 to 2017 focused on a 120,000 square kilometer area along the 7th arc. It was based on the assumption that the plane flew straight south after the final turn, ran out of fuel, and dropped into the ocean in an uncontrolled descent. They searched that entire zone, found nothing. So they revised. In 2018, Ocean Infinity expanded to new areas based on refined satellite analysis and updated drift models. Another 112,000 square kilometers. Still nothing. Now in 2026, they're searching a new 15,000 square kilometer box based on even more refined data. And they're still finding nothing. Every time they refine the data, the target zone moves. Every new piece of debris that washes up changes the drift models. Every updated analysis shifts the probable crash site. The flaperon that washed up on Reunion Island in July 2015 arrived earlier than the models predicted, so oceanographers added new variables: windage, perpetual motion currents, seasonal variations, to make the math work. Each adjustment changes where they think the plane went down. 33 confirmed pieces of debris. Each one refines the models differently. Each one points to slightly different origin points. There's no single location where all the evidence converges. All of this, every search, every model, every probability calculation, is based on one core assumption: that MH370 crashed into the ocean conventionally. But what if it didn't? Ashton Forbes' teleportation theory. I'm going to spend some real time on this because it's controversial, but it ties directly into why finding MH370 might be literally impossible. Forbes bases his theory on leaked video footage, allegedly from 2014. 2 videos, one supposedly from a military drone, one supposedly from a satellite thermal camera. Both show the same thing: MH370 in flight, surrounded by 3 glowing plasma orbs, and then, flash, the plane vanishes. Now, debunkers immediately jumped on this. They said the video came from video game assets. Forbes fired back with thermal analysis. Here's his theory. US military technology, possibly DIA, possibly Lockheed Martin Black projects, used an aneutronic fusion device inside or near the aircraft to harness zero-point energy. We're talking electrogravitics, magneto-hydrodynamic propulsion, the creation of a relativistic wormhole using exotic matter to bend space-time. Those 3 orbs? They're not UFOs in the alien sense. They're anti-gravity craft using negative energy extraction to open a portal. A polyhedral wormhole configuration based on Kramer-Woodward physics. Basically, the plane didn't crash, it was teleported, removed from our reality and sent somewhere else. Maybe Diego Garcia, maybe somewhere we can't even access. Why? There were 20 Freescale semiconductor employees on that flight, Chinese scientists working on superconducting microchip technology. After MH370 disappeared, patent rights consolidated. Follow the money, Forbes says. Follow the power players who benefited. He ties it to recent UFO leaks. The New York Post ran footage of similar orbs in the Middle East, the same plasma signatures, the same flight characteristics. He's linking MH370 to a broader pattern of advanced aerospace technology that governments are hiding. Critics call it pseudoscience. They call Forbes a conspiracy theorist running a grift. If it's true, if MH370 was teleported, then every conventional search is pointless. You're not looking for a plane that's impossible to find. You're looking for a plane that's not there. It explains the silent emergency locator transmitters. It explains why no debris field was ever found in the search zones. It explains the government's silence. It explains why, after 12 years and $200 million, we found 33 pieces of debris but 0 wreckage. And that brings us full circle back to Titanic. Remember what made Titanic possible? Known location, manageable depth, unlimited funding, proven strategy, 8 days of searching.